All right, we're right on time, so we want to get started right now. And welcome to our session, Presto Optimization with Distributed Caching on Data Lake. And my name is Hope Wang. I'm from Alluxio, and I'm here co-presenting with my colleague, Beinan. And you guys should be very familiar with Beinan because he is a TNC member of Presto project. And I'm the developer advocate of Alluxio and also contribute to a Presto project. I also assume you'll be very familiar with Alluxio, right? If not, Alluxio is an open source project started from UC Berkeley AMP Lab, and we build a data access layer, which is underneath is a distributed caching on top of object storage or your data lake to serve data to both analytics and big data workloads. So today we want to talk about caching because we are the core technology of us is caching. And you know that a few years ago we built the Raptor X project. That is, we are the original creator of the Raptor X project. And we also have the system cache, which is Alluxio. And today we're going to talk about something that is very new. That's our new open source product as well as our latest development or the new stuff of caching. Hope you enjoy. And first, I want to talk about why caching matters. So in that we should have a look at the evolution of the modern data stack. We want to take a look at what has changed from 10 years ago, which is the Hadoop era, to right now, today. And I'll highlight the three most impactful trends here. And the first one is highly coupled MapReduce and HDFS to the compute storage separation. And before, think about 10 years ago, we have compute and storage very tightly together. And now we usually have object storage paired with a computation engine, and that is not as the same as 10 years ago. And the second trend is from on-prem to cloud data lake, which is not only you're migrating your workloads to the cloud, you're also utilizing cloud as your source of truth for your data lake, as most typically your S3. And I want to mention that usually both or a mix, because we work with a lot of large technology companies as Uber or Meta or TikTok. Sometimes they have both on-prem storage as well as cloud data lake. And adopting cloud data lake, it will be, you have more scalability, it's managed, and also it's cheaper. And a third trend I want to mention here that's related to the topic today is from Yarn to Kubernetes or containerization. And beforehand, Yarn was the standard for Hadoop cluster management. And now we have Kubernetes serving as a standard of container orchestration. So it will be much more easier and more adaptable. So, everything here I'm mentioning is leading to for your data infra to be more elastic, cheaper, easier to manage, and more scalable. And however, as you can see, you can think about something that is called data locality, if you're familiar with this term. And all of these trends have led to some issues or some challenges related to data locality, because now we have separate compute and storage, and usually it will take some I/O path from your cloud data lake S3 and then feed the data to your Presto nodes or Presto engine. So it relates to some kind of I/O optimization is required. And also Kubernetes, the job scheduling, is also missing a data locality here. And caching, it's something related to data locality I'm talking about today. So think about the implication of lack of data locality, right? And first of all, it might affect your performance, like your query latency, right? A lot of the companies, they have cross-region or remote S3 they want to access to, and maybe also a hybrid cloud. The query latency might be not stable or cannot meet your demands. And also, cloud storage costs. It's related to the number of requests, and it's also related to how much data is transferred through the network if you have egress costs. And also it's about the manageability of your platform. For example, if you have some kind of many different teams managing S3 from different regions, you might need to replicate data from one region to another to get the locality and to reduce the egress costs. This can be very complex, and it can also occur a lot of data copies. And if you have any other workloads using different APIs, it also be something that's your management burden. And we want to talk about caching today. I want to share a number here. It's something that number that from what we've seen of the data access pattern or the IO pattern from the companies that we work with, that only 10% of your data is hot data, which means only 10% is something that you are frequently access data. Maybe some of your users have a table that is very, very frequently accessed. However, others are not. So not all your data is hot, which means we actually have a chance to use cache to solve the slow latency problem as well as manageability problems and the related to data locality. I'll take Uber as an example because we work with Uber's HDFS team a lot and also their Presto team a lot. And only like 1% of their Presto disk space can handle half of their frequent data access, right? So if only you can allocate like 1% of your disks for cache, you have very significant performance and cost effectiveness gains by cache. So I mentioned about caching, right? We talk about data locality. Data locality means you place your computation the same place as where your storage is. And caching is bringing your hot data to compute. It's bringing data close to compute, that approach. Because not all your data is hot, so it doesn't mean like you will bring a lot of data to your compute. You only bring that hot data. So there are 4 values caching provide. And the first one is performance. I have here a diagram here showing why using cache will be fast. It will be fast, especially if you have IO-bound queries. So the reasons causing you have slow queries or you want to do the performance tuning might be a lot of different reasons. But if you have you have found that your queries are IO-bound or you have a remote storage, so the IO would be greatly shortened once you adopt the cache. You can see from the diagram here, with cache, the total job runtime is reduced because you're reducing the IO here, right? Another one is about cloud storage costs. I don't know like how familiar you are with cloud storage. I know the fund is probably very small here, but I can talk through it a little bit. You can think about cloud storage costs can be divided into 2 parts. On the left-hand side is the operations or number of requests charged by a number of requests. So think about it under the context of Presto. That will be a get or list operations. And on the right-hand side is the data transfer cost, which applies when you have a cross-region or hybrid or multi-cloud. So if you have S3 in US East 1 and S3 in US East West 1, and that egress cost or data transfer cost will apply. You might think about this like per 1,000 requests is a small number of pricing. However, it really adds up very quickly because like your the cost really depends on how frequently you do the queries, right? And then I also want to take Uber as an example. They have a really large Presto fleet with 500,000 of queries per day, which means if they are moving their storage from on-prem to S3 or GCS, they have a very huge number of cloud storage costs. So the cost portion is really huge to impact their decision of whether or not they want to move their data lake to the cloud, right? And also we come across a lot of different kinds of open source users adopting Alluxio because the data transfer costs really hurt. And it also adds up. It's like a hidden cost and you have no idea until you get the bill. It's related to the amount of data transfer through the network. So it depends on how frequently your queries or the data needs to be transferred from the network from one region to another. And caching can help here. I have listed like a diagram here. You can see like caching. Without cache, you're frequently retrieving data directly from your different region of S3. So, and then with cache, it's only retrieve the data when necessary. It's the first time when retrieving data, and it will be stored in the cache if it's hot. And then the next time when you're retrieving data, and it will be from the cache instead of directly from S3. So the number of requests will be greatly reduced. From what we've seen in Uber, is it reduced by what percentage? You know, Beinan? At least 10% or 10 to 30% of the number of requests directly to the storage. So it can be relieved by the cache. Another benefit here is reliability, because people's challenges are different. And some companies or some organizations, users, their challenges are really about, they have a very limited bandwidth of network. So if they are having very like frequent load on their Presto, so their network might be congested when they're having some network spikes. And the same applies to the under storage, because there are some limitations of how many requests under storage can be done. So having a cache here can serve as a buffer or shield to protect your storage from being like overloaded. So caching can, like, just in one word, caching can provide 5 values and can bring hot data to compute for locality. So next, I want to hand it over to Beinan to talk about more technical stuff and diving into many types of caching in Presto, and also what Alluxio is working on, something new for users that you might be interested in.
Thank you, Hope. I will continue this presentation. I will share more technical details about the caching, the cell phone. Okay, so actually, Presto is open source project. So many tech giants like Meta, like Uber, like Twitter. We don't have Twitter anymore, but anyway, they are contribute the cache technology into Presto for many years. See, we have at least, actually the implementation of the cache is more than that. I just list 5 of them. I think that's this 5 cache is the most frequently used cache in Presto. You can see some of the cache, they are caching the metadata of the file. They are working in the coordinator, and mostly they using the storage, using the memory as storage. And some of the cache, like the fragment result cache, like the Alluxio SDK cache, they are more like a data cache. They cache the raw data or maybe the intermediate results. They are taking advantage of the disk, the local disk of Presto workers. And on the other side, we can also have a standalone or separate cache cluster. We call Alluxio system cache or distributed cache. You can deploy whatever, how many nodes you like into another machines or node, or maybe you can just do the co-located Alluxio with your Presto workers. And also you can use memory, SSD, HDD to provide a much larger capacity of your cache. The first one. Today, I'm not just to give you some technical detail. I want to give you the evolution of this kind of cache and how we can use it. The first one is the metastore cache. Because sometimes when you are running Presto, your Hive metastore probably will be the bottleneck, because the Hive metastore is backed by MySQL, right? So in this case, because actually the planning time for each query is much small, but the workload to a Hive metastore might be big. So in this case, probably you can use a metastore cache, just caching the something like the partition list from your Hive metastore. It can reduce the workload of your Hive metastore. And also on the other side, if you're using HDFS, probably for each partition, you will list all the files in this partition. And in this case, you might overload your HDFS name node, right? because I was working with the HDFS team for a long time. They always complain Presto. Presto is too strong to scan the data, to list the file. They will send hundreds of requests every second into the name node. But actually, the HDFS is not very scalable, I have to say. It caused a lot of trouble there. On the other side, as Hope mentioned, you can find the price. The price of the cloud storage is not free. The price is counted by the number of API call. But if you look into the price list, the rating, for the list will be 10 times expensive than any other operation. So which means it costs a lot. Because if we're talking about the Presto table, especially for the Hive table, for each partition, it will perform a list. So if you have 10,000 partitions, you will list 10,000 times. That's why we have Asperger, that's why we have Houdini. But somehow, in some time, we still need to do the list. So in this case, we can enable the file status cache to cache the list result from your HDFS or from your cloud storage. Okay, this one, I'm not quite sure it's a production ready or not, because the owner of the fragment result cache, I think he left. It's Shixuan. He left Meta, I think 2 or 3 years ago. And you can see if we're talking about the configuration, there's still some experimental things there. But I heard quite a few company actually that they are using this kind of thing to speed up their query. So this one is really helpful if you have something query like the aggregation, which means you scan a lot of data and you get a summary of this kind of thing. You can just cache a summary, maybe the number of aggregation, the average, the sum. But you can got from something can got from a footer, but sometimes if you need to scan something, this one is really helpful. It can 100 or 200 times speed up your query. But there's some limitation. You can see here. For this one, you need to enable the soft-affinity. Just because, as I mentioned, most queries do something like table scan and then do some filter and do some aggregation. But if you enable the fragment result cache, you need to make sure the same task, the same subtask should be always go to the same worker, and then you can reuse the cache. If you schedule the same task to other workers, they might be not hit your cache, it will cache miss. You need to recalculate the result again. Okay, this is the open source project owned by us. It's a Alluxio SDK cache. It's something running in the Presto worker, and it can cache the data, the raw data from HDFS or S3, because the Presto is we call the compute storage separation. It's a storage independent computer engine. So every time you do some table scan, you will load data from remote. So in this case, probably if you have a local cache in your workers, you can cache the most hard data. As Hope mentioned, the hard data is only 10%. But actually, as we observed from Uber, they only use 1% of cache capacity. They can cache more than 50% of their traffic because they have very limited local SSD. So the total cache capacity is just 1%, less than 1% actually. And also, mostly because if we're talking about the server running Presto, the Presto, mostly, they won't spill the data, the splits, the page into a disk. So the disk is just spared there. No one's using it. So with this technology, you can just reuse your spare hardware resource. Yes. And this one is our system cache. As I mentioned, they can provide almost unlimited cache capacity because you can use some. Because for mostly, if talking about the machine running Presto, you may use some CPU-intensive machine. It should be more expensive than the storage machine. So in this case, maybe you can get some cheaper machine running some cache to provide a much larger cache capacity. This one is super useful if you have some remote data set, another story, another region, like Hope mentioned. It will be the egress cost will apply there. So we can have a separate cache cluster, just cache data from remote. Okay, here's the comprehensive list talking about what kind of a cache we have and when we can use it. I think I already covered most of the ideas about when to use it and what's the limitation and what's the benefits of using this kind of thing. But you can think about it, it's really a lot. Because I only list 5 of them. Actually, there's maybe another 5 or another 7 cache technology in the Presto, right? It's really difficult to tune each of them. You need to manage the configuration. You need to think about how to balance the memory, SSD, and the hardware to get the best result. And maybe sometimes you don't know which one you should enable, which one you should disable. Because sometimes cache will give you trouble because you may cache some data is not fresh. So in this case, we have something really new. We call it Alluxio Edge. It's more like an all-in-one solution, which means talking about the 5 cache in my previous slide and also some other cache. Now I think you can disable them just to use Alluxio Edge. And you can, it's also something, it's not something standalone. You can deploy well, you can also deploy, you just need to, I can cover this slide later. So it's more like a library, a jar library. We can put it into the Presto and it's running the Presto coordinator and the workers. It can support, as I mentioned, it's also using SSD. It's free SSD there. And this one is compatible with Iceberg, Hoodie, Data Lake, and Hive tables. And also this one, it also supports CSV, JSON, TXT, because the previous data cache, the Alluxio cache or RaptorX cache, they don't support CSV, JSON, and text. They only support the columnar data format like Parquet and ORC. And also they have some trouble about the data lakes, but for the Edge, we support all of them. You can use everything you want. They can accelerate all of the kind of query, table format, and the data format. And also we add a dashboard. We had a dashboard we call Edge dashboard. I will show it later. And you can deploy in your data center. Maybe you can also use our centralized dashboard to collect some data. Here's some architecture design about how to make a Alluxio Edge. The Edge is the new local cache, or we can see the cache built in Presto, and the Dora is something like a separate cache cluster. It's a distributed cache cluster, can give you a limited cache space. So they can work together, especially when you have some data remote, some remote S3, you can use a Dora in the middle, which means probably you can use the Dora cache to cache maybe 10% or 20% of your data, and using a Alluxio Edge cache like a local cache running on the Presto JVM or workers, this can take care maybe just 1% of our data, the most hot data put in the Edge. You can see the Edge is actually just running in the Presto worker and the Presto coordinator. It's in the same JVM process. Because as Ho mentioned, because now we all use Kubernetes. You may find the technologies we are using for data locality, like co-located, like we deploy 2 processes just in one physical machine. It might be not perfect work on the Kubernetes, because if you're talking about the same physical machine, they may have different pods. Different pods maybe have different IP address. So in this case, we choose to make the actual Edge cache running in the same JVM process. They share the same memory, the same disk, and the same IP address. They can work together closely. And we also provide the metadata caching, and we also provide the virtual block locations. This one will impact the scheduler of the Presto coordinator. And which means we will have the Presto coordinator, because Presto coordinator can do the scheduling based on the address of each block. So we give them some fake block address. So which means we can reduce the chance of the hot node, because if maybe some of the most hot file will always go to the same worker. But by doing the virtual block locations, we can prepare some fake locations, and they can reschedule the hot data to other workers. Okay, so here are some results we observed from our customers. You can see a much faster query latency, and you can also got some flexibilities from our edge because we can just deploy with our Alluxios. Also, as Hope mentioned, sometimes caches can highly improve your reliability of your storage and network. Here are some results we collect in-house from a TPC-DS. We can see for most TPC-DS query, we got a very good result. And for the first round, even for the first round, we are seeing we are getting faster for the code read wide. Just because the edge can merge the tiny request to S3 to a bigger ones. Because the Presto may be fully optimized for the random read, it will always try to seek the data from the same packet files. So in this case, by using Edge, they can merge the read request from remote into 1 megabyte page. So can highly reduce the number of requests and also improve our performance. And also for the installation, it's super easy. As I mentioned, you only need to copy the Alluxio enterprise jar into the Presto work and the coordinator, and then you can restart your Presto, maybe change some configurations, and the cache can be enabled and serving for you. Here's the dashboard I mentioned. You can see we can watch the status of the running cluster, and also you can for this part you can have some knowledge, some insights about how much we saved, because that's the whole mission, the cost, the API cost, the egress cost. We can have some estimation here. You can see by enable the cache how much we saved. And okay, the last one. I think Hope and I we have a book. We have a Presto optimization handbook. It's not just talk about the cache, we also talk about the general optimizations, about the Presto DB, something like a dynamic filter, something like the broadcast drawing. You can scan the QR code. We can download the free version. It's free, right? Okay. Yeah, it's a free book.
The best performance tuning tips you can get, because it's drafted by Beinan. He is the real expert here, and he can solve anything that people cannot solve. It's just like a magic. So this book contains all the magic he has. Highly recommend to download for free. And I think that's all for our talk. Any questions? And I'll just leave it here.
So you mentioned that you're running the same JVM as Presto. So obvious next question is, how will that work with VLOX?
That's really a good question. So currently, for the implementation we're talking about, it's a pure Java solution. It's running on the JVM. And we are working on a Rust native version of cache. They can be pluggable. We are also working on some native packet reader with some tech giant together, because we really need a native cache solution which can deeply integrate with the computer engine. We want to provide some semantic cache or something. I presented this topic last year, actually. So we want to have another kind of cache can work with the native VLOX or Rust packet reader, can give you a native cache solution. That's the future plan.
That's the roadmap.
Yes, we are working on that. Yeah, but it's not production ready. We have some code there, but it's still not production ready. It's a good question. So we highly recommend for the edge, we just one level cache. It's all in the local NVMe disk. It can provide the best performance. Yes, the NVMe. But some of our customers, they don't have local NVMe because they are using Kubernetes or something. They can also use memories in case they have larger memory. Or some of them, they use a very slow SATA disk or something. It's also okay. So we can have different settings for the storage.
Yeah, you can do the configurations of what storage you want to use for that. But most typically, we see the NVMe SSD disks are the most common.
It's a balance of the cost, performance, and the capacity.
Working like
I have to say the data spill in Presto, it's more like a backup. It's more like something like if we are hitting the bound of memory, we are getting out of memory, then we spill some data into the disk. It doesn't mean we always spill the data to the disk, right? So in this case, we have to say, yes, there's some resource confliction, but mostly the cache is used for speed up the data loading from remote. But the data spill is helping the Presto to handle a much larger data set. So it's for different purpose, but they can share the local disk.